Okay, the next example, we're going to determine if Rolle's theorem can be applied, and if it can, all the values of C that can satisfy the theorem. If not, explain why not, and you have to explain why it cannot. All right, so remember what the criteria is, and I lost my toolbar, so let me get that back up here. Remember what the criteria is. The criteria is if the function's continuous on the given interval, then it's differentiable. So if those two things are true, we're good. And then you plug in. So we'd plug in f of negative 3 and then f of 3. If those two values equal each other, then we can proceed. And there should be a value that satisfies Rolle's theorem. So the first thing, let's check to see if it's continuous. Well, whatever zeroes out the denominator makes it discontinuous. So in this case, when x is equal to 0, it will be discontinuous. Well, 0 is in that interval. So if you've got negative 3 and positive 3, and you've got a graph that's doing some stuff, well, right in the middle of it, there's going to be an asymptote, which means that graph will not be continuous. So since that graph is not continuous, so for your reasoning, you would say Rolle's theorem, if you want to make your professor happy, doesn't apply, and you probably should say on this interval, because where x is equal to 0, which is in that interval, the function is not continuous. So that is what how you would explain, or maybe let's say it was continuous. If it was continuous, it's differentiable. But let's say when you plugged in negative 3, it did not equal f of 3. Then that would be your reason. You would say Rolle's theorem doesn't apply on this interval. And instead of because where x is equal to 0, you would say because f of negative 3 is not equal to f of 3. So we can't determine if Rolle's theorem apply or not. All right, so that's it for applying Rolle's theorem when it actually does not apply.